In this video, we'll discuss about Von-Neumann and Harvard architecture. First, let us start with Von-Neumann architecture. This is also called as stored program or Princeton architecture. So here, what we'll be having is that we'll be having the memory at the top, and this memory will be connected to the CPU. This CPU will consist of the control unit and the ALU for processing arithmetic and logical operations. And this memory and the CPU are connected via bidirectional interface. After this, we'll have the IO devices input and output devices here, which are again interconnected to the CPU. The IO is not a bidirectional bus, rather it's a unidirectional bus. The input is a connection to the CPU and the output is connection from the CPU. So this basic architecture is called as the Von-Neumann architecture. So a major bottleneck of this Von-Neumann architecture is that we have a single memory. So let us consider the processor here and the memory. As we can see, there is a single bidirectional bus between this processor and this memory. So in this memory, we are going to store both instructions and data. Suppose consider a case where I need to fetch both an instruction and also a data. In this case, since memory cannot perform simultaneous read, it is not possible to fetch this instruction and data simultaneously. This is the main bottleneck of this von Neumann architecture. So you can tell that there is a simple solution for this. Instead of having a single bus, let me connect two buses. In this way, visually you can say that we can fetch both instruction and data from a single operation. But the thing is, almost there are no memories, or rather, I can put like it's very costly to design a memory which can do multiple fetches. So this is not feasible all the time. So in order to nullify this bottleneck, we are moving to a different architecture, which is called as a Harvard architecture. In this Harvard architecture, what we do is that we have a processor and we have two memories. First memory is dedicated for instructions, and the second memory is dedicated for data. This is the instruction data memory, and this is the instruction memory. So we have separate bidirectional buses to each of these memories. Uh, but practically, the thing is, Harvard architecture is not implemented nowadays. There are very few processors which are implemented using this Harvard architecture, mainly because of the cost. The cost increases when we have separate data and instruction memory, and in many cases, we don't need this type of memory architecture. This is it turns out that we can remove these bottlenecks by using caching and pipelining. So what we do is that instead of using Harvard architecture directly in processes, we will be using Harvard architecture in cache architectures. So the cache architecture will go like this. What we do is that we will have a CPU and we will have a small cache called as the iCache, which stores the instructions that are frequently accessed, and we will have a separate D cache, which is for data, and this is usually a level 1 cache. After this, we will have a level 2 cache, which will be sort of a unified cache. This will store both instruction and data, and this unified cache is usually connected to the main memory. As you can see, this is a more feasible and cost-effective architecture, which can remove the bottleneck of this Von-Neumann architecture to some extent.